Hello students, welcome back. In this brief lecture, we are going to discuss about weed management. As you know, weeds are the plants which are undesired in our crop field. That means Harlan and Dewitt, they propose three types of plants are there in nature. One is crop plant, that is our desired plant, which we grow, which we uh, take care of, that is crop plant, and we grow it in large areas for production of grains, fodder, fiber, all different purpose, and for consumption as well as marketing. But any plant that is competing with our desired plant, that is called undesired plant, and that is known as weed. Okay, that is known as weed. The first weed, the term weed was first introduced by Jethro Tull in his book Horse Weighing Husbandry. As you know, he has written the book Horse Weighing Husbandry. So Jethro Tull first introduced the term weed, and weeds are unwanted plant and they compete with our crop plant, that is our desired plant. These weeds are unwanted and they grow out of place and extremely noxious. Okay, crop plants are generally, as I mentioned, it meets the human need. Now, what are the problems of weed? Why we are concerned about weed? Because see, whatever the biotic and abiotic factor that affects the crop growth, weed poses the maximum crop loss among them, and it contributes around 37 to 45% crop loss. Generally, farmer incur in case of weed infestation, right? It may go up to 100% crop loss as in case of some direct seeded rice or some vegetable crops where weed infestation is severe. Okay, now what are the problems of weeds? What are the problems of weeds? So basically, weeds are having the similar morphological and physiological behavior as that of crop plant. So they require different nutrient, different resources as of crop plant, right? So they compete with crop plant for different resources. They deplete different resources and compete with crop plant. Then extent of losses in case of weed on cropland, it depends on what is the intensity of infestation, what is the time of occurrence, what is the type of weed, which type of weed has been predominated in the crop field, what is the time of infestation, and what is the extent of infestation. All these factor, all these parameter, they actually affect the extent of crop loss due to weed. Okay, now uh, weed interfere in cultural and harvesting practices as well. Some weeds like field bind weeds, some weeds which having some itching effects or spiny weeds, they actually affect the crop management. Okay, suppose we are going for thinning, gap filling, or some interculture operation or harvesting in the crop field. So this type of weeds who is having itching effect or having spiny foliage, they affect the different agronomic practices or cultural practices. Then some weeds, they affect the crop quality. They mix with the crop seed, or they affect some parasitic weed. They affect the quality of the crop. Okay, uh, and their seed when mixed with the crop seed, then it is very difficult to remove them, and it affect the quality of the produce. Some weeds, they harbor different pests and diseases. That means some weeds, they are the house of different pests and diseases. Like for example, these are some of the example which are being asked in different competitive exam. You have to remember them. Like in case of red gram, that is red gram, the pest is gram caterpillar. That is the alternate host is Amaranthus datura. So these weeds, they harbor this type of pest. Then in case of castor, the hairy caterpillar problem is mostly seen, and it is the host plant is Crotalaria species. In case of rice, the stem borer is one important pest, which is the host plant here, or uh, the weed which harbor this type of pest, that is Echinoclea and Panicum. In case of wheat, black rust, and the host plant is Agropyron repens. Then pearl millet or bajra, the ergot of bajra is most important disease, and the host plant here is, or alternate host is, Cenchrus ciliaris. Then maize, downy mildew, here the host plant or alternate host is Saccharum and Saccharum spontaneum. Then in case of groundnut, pea nut stem necrosis is one important disease. Parthenium histoporus is the host plant here. In case of sugar beet, leaf curl virus, and here lamb scatter or Chinopodium album is the lamb scatter or Chinopodium album is the host plant. Okay. Then in case of maize dwarf mosaic virus is there, so where Johnson grass is the alternate host. In case of wheat, again powdery mildew, and the host plant alternate host is wild oat. So these are some of the weeds which act as alternate host when plant is not there, and when there we grow the crop, then it also affect our crop and reduce the quality as well as yield. Then some weeds they are having direct impact on human health. Some causes jaundice, some causes asthma, some causes skin rashes. Uh, so many harmful effects a weed pose on both crop as well as animals as well as human being. Now, for example, like how weeds causing human health deteriorate human health, like hay fever and asthma caused by pollen of ambrosia and artemisifolia. Then dermatitis is, or skin allergy, it is caused by parthenium and ambrosia. Itching and inflammation when the skin is in contact with Otrika species. African sleeping sickness when there is more weed. Then malaria and encephalitis when there is more aquatic weeds present in the vicinity. Then see, unless and until we know the classification of weed, how they're being grouped, how whether it is annual weed, whether it is biennial, whether it is perennial, whether it is a grassy weed, whether it is one, shrub weed or like uh, like it is having shrubby nature or grassy nature, or it is having creeping nature, or what type of vegetative structure it is, or whether it is C3, C4 cam, whether it is day neutral or short day, long day plant. Unless and until we classify the weeds based on certain parameter, uh, the management is too difficult. Okay, so classification is important. There are mostly 30,000 weeds found in the globe globally. So among them, 18,000 are serious weeds of different crop field. Okay, now, based on the duration of weed growth, weeds are grouped into annual weed, biennial weed, and perennial weed. So, annual weed means starting from its seed set to harvesting or to maturity. This weed takes one season or 1 year for completion of its life cycle. Okay, and again, annual weed based on in which season it is growing. They are kind of Kharif annual, Rabi annual, winter annual, or summer annual, or multi-season annual. Okay. Then biennial weed, they are basically for completion of its life cycle, they need 2 season. Okay. In the first season, they complete their vegetative life cycle. In second season, they complete their reproductive life cycle. See, these are some of the broad lectures. I mean, we have already posted dedicated lecture on weed classification, weed harmful and beneficial effect. Then again, different aspects of weed management in our uh, previous lectures. You can check them out, as well as there is a folder called weed management. I mean, there is a separate playlist that is called weed management or written weed management. You can check that as well. So this is brief classification of weeds. Then, like considering the problematic weed, the world's worst weed, it is proposed by Hole Metal in 1977. That is called Cyperus rotundus or purple nodses. That is world's considered as world's worst weed. Okay, so how weeds survive better than crop? So there are certain characteristics through which wheat can survive better than crops. Okay, like it is having high seed production ability, and seed dormancy is a major factor in case of wheat. Okay, then dormancy, then vegetative mode of reproduction. Also, many weeds they can propagate through vegetative means, so that is another advantage. Then root system, then types of photosynthesis. Mostly weeds are C4 in nature and which can accommodate in a different, changing climate scenario, right? Then considering the seed production capacity, like barnyard grass, you can see one plant can produce 7,000 or 8,000 number of seeds. Lamb's quarter or chinopodium, it can produce around 70,000 seeds. Yellow nurses produce around 4,000. seeds, and they are very minor seeds, so they can be easily blown by wind, they can disperse easily through wind or water. Okay, they do not need human interference for spreading out, right? Then if we consider weed growth stage, different crop plant as well as weed, they are having certain growth stages. If we know the growth stages where we can manage the weed properly, then we can manage them efficiently, right? So what are the weed growth stages? Like germination, considered as they are numbered as 0 to 9. So germination is numbered as 0, seedling 1, tillering 2, like that. So there basically depends on weeds. The growth stages also depends on which type of weed it is, whether it is monocot weed, whether it is dicot weed, whether it is a grassy weed, whether it is a broadleaf weed, whether it is a sage. So it depends on the type of weed. The growth stages depends. Then coming to crop weed competition. So whenever any two organisms they live together and they require similar kind of resources. See, when we're talking about weed and crop, they both are plants, they both require the essential nutrients, the water, air, okay, space, solar radiation for their survival, because their morphology and physiology kind of similar with little bit difference, but they're similar, right? So they require for their survival they require similar amount, similar type of resources. So they compete with each other. If the resource is not limited, then there is no need of taking care of competition. But as the resources are limited, so that's why competition happens between weed and crop. And this competition is not only confined to ground level, it is also confined to upper level as well as below ground level. So above ground level, weed and crop they compete with each other for light or solar radiation and carbon dioxide. Below ground level, they mostly compete for water as well as nutrient, right? So some weeds are there, they actually accumulate more nutrient than cropland. Like for example, amaranthus, it accumulates around 4 to 5% of nitrogen. So it is a nitrogen loving weed. Then potassium lover like Portulaca chinopodium, phosphorus lover like Digitaria, zinc lover like Setaria. Okay, so they actually accumulate more nutrient than the cropland does. Okay, so basically we need to concern about this type of situation activity, because weeds they basically we were not getting any grain or any economic product from weed. Though some beneficial aspect of weeds are there, but most of the weeds they are not useful for us unless and until they are domesticated and become crop. So and they're taking huge quantity of nutrient from the soil, so that is a concern. Okay, they deplete the nutrient status that supposed to be availed by crop plant, right? Then they compete for nutrient, they compete for light, compete for water, uh, compete for carbon dioxide, and they're having allelopathic effect as well. And that is not competition, but that is one direct effect. Allelopathy is one direct effect. That means they release some allochemical, and that is having negative impact on surrounding crop plant, right? So let's discuss about critical crop yield competition. That is important from exam point of view. See, critical crop yield competition means the period in the crop cycle when weed causes maximum crop loss. And in other words, you can say if we are controlling the weeds we can get maximum yield, and in other words, if we are allowing the weed to grow in that particular phase of the crop cycle, then weed causes maximum yield reduction. Okay, so it is the shortest time span during the crop growth cycle when weeding results highest economic return. Okay, and if we talk about one thumb rule, that is if the crop duration is X, so 1 by 4th to 1/3 of the crop duration is called critical. Okay, for example, in rice 15 to 45 days after sowing, in a plant rice whole duration of the crop, and black gram 30 to 45 days after sowing. In case of sugar cane it is 40 to 120 days after sowing. So that is critical crop yield competition period. Okay, so there are different factors affecting critical crop yield competition, like nature of crop, variety, growing condition, all these, and management aspect, all these affect critical crop yield competition period. Now coming to establishment of weed, if we are talking about establishment of weed, Weed dispersal plays a major role. So weed seed, how it proliferates from one place to another, how it moves from, because human doesn't interfere in weeds movement. We are not cultivating the weeds, right? So weed move and weed germinate, weed establish themselves. Okay. So there is some autocory mechanism, some weeds having pappus, comos, balloon type structure. They have self dispersal structures. So that is called autocory. So movement of weeds by themselves, by their own, that is called autocory. Then allocory mechanism means we dispersed by any agent, that means either wind or water or animal or birds. Okay, so that is called allocory. Allocory are of different type like myrmecocory, anemocory. Okay, so there are different types of allocory mechanism. Then germination. So if we're talking about germinations, that is basically the seed bank of the weeds. So basically, soil is act as seed bank. Most of the weeds they germinate from shallow layer. I mean surface germinating, then shallow germinating, deep germinating. So mostly weed seeds they germinate from the surface layer. Okay. Then coming to seed bank and seed rain. Seed bank means storage of the seed in the different layer of the soil, and seed rain means falling of the seeds from weedy plants. Okay. Then about dormancy. Dormancy is the suspended growth or any unfavorable condition if it happens and there is the germination is suspended. So weed survival of the weed also significantly affected by the dormancy. Okay, variable dormancy. And if we are talking about dormancy, there are three types of dormancy like innate dormancy, induced dormancy, and enforced dormancy. Wild oat, that is Avena fatwa, it contains all three types of dormancy. For dormancy breaking, we can use gibberellin and ethylene phytohormone, and ethylene also act as suicidal germination for striga. Then longevity. Wheat seed has having higher longevity. Some report has been found that wheat seeds can germinate even after 30 to 50 years underground. Okay, of suspended growth. Then periodicity. 1 year weeding is considered as 7 years seeding. 7 year 1 year seeding considered as 7 year weeding. So once the weed plant set the seed in the ground, so this seed, some are dormant, some can currently germinate and emerge. So they will store in different layer of the soil again. Okay. So during tillage also there is seed turnover of the weed seed. So 1 year the wheat plant sets seed or seed rain happens, then there is several years to that will infest that particular field. Okay, so that's why prevention is considered to be better than cure. So we have to control the weeds. If it is annual weed, then we have to control it before flowering, because once flowering and seed set happens, then that is very difficult to control. Then cultivation practices like night tillage reduces the weed germination, minimum tillage increases the population of perennial weed, right? So in minimum tillage, we are not disturbing the soil much, so perennial weed infestation is more in case of minimum tillage or zero tillage condition. Now we have studied about different types of weeds, how critical crop weed competition happens, how what is critical crop weed competition, what are the factors. Now coming to weed control methods. So there are different weed control methods available. One is cultural aspects. So basically by modifying the cultivation practices, if we can manage to control the weeds, that is called cultural practices of weed control. For example, tillage, planting time or planting methods or spacing, then fertilizer application, irrigation, cropping system, smoother crop, using smoother crop. If we can manage the weed, then that is called cultural weed. Like trap crop, catch crop, that is also we can use in cultural method of weed control. Then physical method of weed control like hand weeding, hand hoeing, digging, mowing, cutting, dredging, chaining. Okay, uh, this mulching, intercultivation, these are called physical method because here physical energy is being utilized. Then chemical method of weed control means using herbicide. For example, 2,4-D, it was synthesized in 1944, and herbicides are of again inorganic herbicide, organic herbicide. Mostly we use right now the organic form of herbicide. Previously, inorganic form was mainly used before introduction of 2,4-D as herbicide. Then herbicides are of different types. We will discuss later on, and you can find other lectures in our channel where we have clearly mentioned about different herbicides. Then biological weed control, like we have classical bioagent approach and bioherbicidal approach. In bioagent approach, we mostly control the exotic weed or alien weed through introduction of different insect pest, okay, which can kill that weed. Then bioherbicidal approach, we can use different fungal spore or fungal pathogen after inoculation. So that is bioherbicidal approach. For example, Lantana camara. Lantana camara was effectively controlled by use of Octotoma scabrifernis or Europlata giraldi, even Crossidogemma lantana. Then prickly pear opuntia, it is controlled by Dactylopus tomentosa. Alligator weed Alphanthera phylogeroid controlled by flea beetle or Agassicle hybrophylla. Then the most common example is Parthenium, that is controlled by Mexican beetle, that is Zygoramma bicolorata, right? Then there are different group of herbicides actually available, and based on different group of herbicide, there are mode and mechanism of herbicide action that is different. Okay, so group of herbicide means some are phenoxyacetic acid, some are amide, some are quaternary ammonium, some are imidazole, okay, some are triazine. So their mode and mechanism of action is different, and we have separate lectures for that. Then herbicide formulation. Formulation means if we are preparing some herbicide and we are making it formulated, that means in usable form, okay, so as such the toxic chemical we cannot apply it over the weed, but we have to formulate that, we have to add some adjuvant, we have to add some carrier, so that is a formulation in which it is being marketed or in which form it is being used in the for the controlling of weed, right? So that is the formula. So there are different formulations available in the market, like soluble powder in case of 2,4-D-sodium salt, TCA, uh, endothal, dalapon, then soluble concentration concentrate in case of 2,4-D-amine, dicamba, paraquat, diquat, wettable powder in case of atrazine, simazine, isoprostone, diuron, EC in case of 2,4-D-ethyl ester, alachlor, nitrofen, dialate, then granular form like butachlor, 2,4-D-ethyl ester. So these are some of the formulations available in the market, common formulation available in the market for herbicides. Then mode and mechanism of action. See, suppose this is weed and we are applying something, suppose this is root, stem and leaf. We are applying herbicide over the weed to control it. So starting from the entry of the herbicide to translocate of the herbicide and to reaching the to the site of action, let's say here, and to final action, complete process is known as mode of action. What is mechanism of action? That is the actual site of action, what actually it does. Basically, let's say suppose mitotic mitosis inhibitor, let's say protein synthesis inhibitor, let's say photosynthesis inhibitor. So these are specific action by a herbicide in the weed, so they are called mechanism of action. If something is asked like mode of action, then you have to write starting from the absorption, how it is being absorbed in the plant, whether it is through canopy, whether it is through root, whether it is through stem, then how it is translocated, like apoplastic movement or symplastic movement, how it is affecting or the mechanism of action. In combination total, it is called mode of action, right? So there are some of the important mechanism of action we're discussing, like photosynthesis inhibitor. So some herbicide they actually affect on hill reaction like triazine, urease, carbamate. Some herbicide they reduce the electron transfer like triazine, carbamate, uracil, okay, anilide. Then some divert the electron like bipyridinol group like paraquat, diquat. If you apply that, they divert the electron. Then some reduce the carbon dioxide fixation like oxidizing. Then this was about photosynthesis inhibitor, and mostly 50% of the herbicides we use, that is photosynthetic inhibitor in nature. Then inhibit respiration. Some herbicides they inhibit the respiration like oxidative phosphorylation like ADP to ATP conversion. For example, dinitroaniline, dinitrophenol, anilide, this inhibit respiration process. Then inhibit biosynthesis of protein. For example, butachlor, alachlor, paraquat. Okay. Then lipid synthesis inhibitor like thiocarbamate, like trialate, dialate. This inhibit lipid synthesis. Then pigment synthesis inhibitor like amitrole, norflurazone. They inhibit the pigment, different like chlorophyll, plastocyanin, plastoquinone. Okay, they inhibit that. Then inhibit vitamin synthesis like dalapon. Then inhibit cell division like our pendimethalin. Okay, inhibit germination, inhibit the abnormal development like 2,4-D. Okay, so there are different mechanisms of action we have already covered in different lecture. Then coming to selectivity of the herbicide. Selectivity of herbicide means whenever we are applying some herbicide or a herbicide in the mixed flora of crop and weed, crop is not affected and weed is getting killed. So that process, that phenomena of selectively killing the weeds, that is called herbicide selectivity. And this herbicide selectivity can be attained through different means like physical selectivity, chemical selectivity, chronological selectivity, as well as biological selectivity or biochemical selectivity. Okay, so this herbicide selectivity can be due to differential absorption, due to differential translocation, due to differential metabolism in the plant. Differential absorption means the rate of absorption also affects the selectivity process. Differential translocation means how it is being translocated. Then differential metabolism rate, metabolic rate means if any, I mean whether it is crop plant or weed plant, if it is degrading, that metabolism means degradation pathway. If it is degrading that herbicide molecule at a faster rate, then the herbicide, the toxic effect of herbicide will go away at a faster pace. So there it will not affect that particular organism. Okay. Now selectivity can be induced by, I mean, antidote, adsorbent, then activated charcoal we can use. Then we can use saphener as well. Like saphener means like Na. Na is one saphener. Okay, it is very mm, I mean famous saphener, and it was the first saphener that is being used. That is 1,8 naphthalate anhydride. Then R25788, that is another saphener, that is NN-dialyl 1,2,2 dichloroacetamide. Then CGA 43089, that is alpha sano uh, amino benzo acetonitrile. So that is another saphenol. Okay, these are example of saphenol. Then method of herbicide application. So there are broadly, if we classify the herbicide application, one is soil application, another one is soil application. Basically, the herbicide, the nature of herbicide, based on the nature of herbicide, we can recommend that whether you to apply on foliage or canopy or to soil. Okay, soil application, there are several methods are there like soil surface application, soil incorporation, subsurface application, as well as band application. Then foliar application, there are different types of foliar application like blanket application, direct application, basal application, coarse surface application. So we have one dedicated lecture on this, how herbicide is being applied. You can check that. Now, herbicide carrier. So as such, we cannot just bring the herbicide container and we cannot just apply it on the weed to kill the weed. We have to mix it with a suitable carrier so that we can spray the herbicide or the formulation throughout the field uniformly or evenly. So water can be a carrier, sand can be a carrier, or dry soil can be a carrier, right? So how to quantify, how to know how much herbicide is being used? See, there is a formula you have to remember, that is quantity of herbicide or trade formulation or trade product that is available in the market that has to be used is equal to dose of herbicide application. Dose is generally listed or written as like 1 kg AI per hectare or 750 gram AI per hectare, like that. So dose divided by active ingredient, that means in 100 ml of that particular product how much herbicide is present into 100. So quantity of the herbicide that you should use is equal to dose divided by active ingredient into 100. What are the factors affecting the dose of the herbicide? That is weed intensity, type of the soil, climate, crop tolerance, okay, management practice, method of or time of application, then economics. Okay, so these affect the herbicide dose. Okay, then there is acid equivalent and active ingredient. Active ingredient I have already discussed ki in 100 ml of or 100 gram of herbicide, that is trade formulation, how much herbicide is present. It may be 40%, it may be 30%, it may be 10%. Okay. See, wettable powder is mostly, it contains most of the active ingredient like 50 to 80%. If we consider granule form, like 2 to 10% it contains the active ingredient. Then acid equivalent means how much acid residue it left after applying or leave after applying on the soil. Okay, that is acid equivalent. Now effect of herbicide on crop, there is some sublethal good effect are there, some bad effect are there like phytotoxic effect are there also. So some sublethal effect like stimulating effect of phenoxy herbicide. Actually, when phenoxy herbicide like 240 mcpa, they are applied at sublethal dose, they, instead of harming the weed, they increase their growth, okay, because they are auxin herbicide. Then triazine, simazine, they are also at lower concentration. They act as increasing the quality as well as productivity of the crop as and increasing the growth of the weed. Then that's why optimum dose should be required or should be applied. Higher dose even uh, has selectivity problem or phytotoxic effect on the crop. Then herbicide resistance, we have a dedicated lecture on this. Herbicide resistance, we have a dedicated lecture you can find in our playlist. Herbicide resistance detailed lecture is there. Okay. Then fate of the herbicide. Herbicide once we apply it, that can be volatilized, that can be absorbed in the soil, that can be leached down in the soil. Then photo decomposition might be there. Then chemical decomposition as well as microbial decomposition is there. So mostly the decomposition, microbial decomposition is affecting the residual effect of the herbicide in the soil. Now soil residue is mainly checked by HPLC. Okay, high performance liquid chromatography. Using this instrument we can use the how much residue is left. Then herbicide mixture, that is, one is tank mix, one is ready mix. Then integrated weed management, when we know, because see, there are different aspect of weed control, like cultural aspect, physical aspect, biological aspect, but every aspect has some pros and cons. Considering the constraint of different aspect or limitations of different aspects, integrated weed management is suggested for different crops. Okay, so that should be economic, that should be viable or economically or ecologically sound, that should be effective enough. So that is integrated weed management. Okay, we have again another separate lecture on integrated weed management. You can watch it. So if you have any doubt regarding weed management or any other lecture you want to have to clarify your doubt, you can let me in the comment section so that we can prepare another lecture on that. See you in the next lecture. Till then, keep reading, keep signing. Ta-da.